So let's take a look at a couple of more flexible and interesting methods that sometimes can come in very handy in our analysis. The first method is cluster analysis. What is cluster analysis? It's basically a classification method that allows us to classify either variables or individuals into homogeneous subgroups. Why do we even mention it today? Well, because actually you can use it sometimes for psychometric purposes. Sometimes if you have a questionnaire where the structure of the items is a little bit complicated, maybe it's hierarchical, maybe you have subscales that are grouped into scales, or maybe items are grouped more than based on one um, source of variance. It becomes very difficult to investigate the structure using exploratory factor analysis. And here cluster analysis can come to our rescue. It can help us to visualize the complex structure of a questionnaire if we classify variables. Another very common task and very interesting task for psychology, we can classify individuals based on a bunch of scores on one or more questionnaires. We can try to classify individuals into groups with similar profiles. And then we can explore what is different about those individuals based on some other variables. And this approach is called person-oriented approach. Essentially, we try to create psychological portraits of individuals belonging to each type. And based on those portraits, we try to make some hypotheses about how those people live and what are the principles that guide their development. So just a couple of words about hierarchical cluster analysis. How does it work? Essentially, it starts from a distance matrix. It takes your raw data, and if you are classifying variables, for every pair of variables, it calculates the distance between them in this multidimensional space. There are different ways of calculating this distance for different data types. And then it arrives with a distance matrix, which is basically how far are every two variables or every two individuals from one another in this multidimensional space. So if you have, imagine that you have distances between cities on a map. This can also be a distance matrix, and you can even feed it to cluster analysis and see how closely are cities located together. So after creating this distance matrix, it starts joining together either individuals or variables that have the minimum distance into clusters. And then it tries to join an individual to another individual or to a cluster. And when the algorithm makes this decision, there are different principles that it can use. Nearest neighbor, farthest neighbor, or median. I will not go into details on all of these because it will take a long time. I will just say that the best method that works with psychological data is Ward's method. And it was used in simulation studies showing that out of these methods that are available in SPSS, for example, Ward's method is by far the best in terms of being able to recover the structure that is really there in the data. So people create this population structure of types, then they add some sample bias, they simulate different samples from this population, and studies show that Ward's method is the best at recovering the true structure. Your source data can in principle be measured on any scale, and this is an advantage to exploratory factor analysis, which can only use certain type of data. Here you can not only use ordinal or nominal data, but you can even use a distance matrix based on some kind of pair comparison method. And some considerations that are potentially important is that cluster analysis is sensitive to rubbish. So try not to include any variables that you are not sure are necessary or maybe that are not very relevant. or if there is a lot of noise in the data, also it might complicate the structure a little bit. And in case if for different variables your means and variances are very different, it often makes sense to standardize these variables to make sure that they have the same mean and the same variance in the same, and then only their associations will contribute to this classification. If you don't standardize them, variables that have similar means, for example, high scores and low scores, can be grouped together, which is often not what we want. Another important consideration is the more variables you have representing a construct, the larger will be its contribution to classification. So if you have 5 different scales on anxiety and 1 scale on depression, obviously the contribution of anxiety to your classification will be 5 times larger. And if you want to equalize it, maybe you need to come up with an equal number of indicators for each construct that you're interested in. And finally, the small consideration. When you classify variables, items for a questionnaire, for example, you might want to classify them based on item direction, for example, to see which are reverse scored and which are forward scored. And then just classify raw items. But if you want to classify them based on content to create scales in the future, it's best to reverse the reverse scored ones to make sure that item direction does not contribute to this classification. Okay, so it's very easy to run cluster analysis, in fact, in SPSS. You just go to classify hierarchical cluster, and there the method that I recommend you to use by default, which was basically shown in the literature to be the best, is Ward's method. If you have a Likert scale, which is our typical scale, just use squared Euclidean distance and standardize these variables to z-scores by variable. This way, every variable will have the same mean and standard deviation, and even if you're classifying individuals, still this approach is the best. And just in plots, we request a dendrogram, and the results of our cluster analysis in SPSS look like this. So it's a dendrogram which reflects which variables are closely connected. So for example, at the first step, we connect upset and distressed, and scared, afraid, and nervous. And then a little bit later, we get jittery. And then we merge all these into one cluster, which will be maybe stress or something. And then we have a separate cluster of negative emotions, which has guilty, ashamed, hostile, and irritable. Maybe these are all the emotions that we get when we have nasty people around us. And it's a separate kind of cluster. And then we join them together, and they become a negative emotion cluster and a positive emotion cluster. So the question is, how many clusters do we have here? And it's basically an arbitrary decision. Ideally, you need to look for the branch where there is the largest potentially gap. Here, of course, it's better to use some statistical procedures, but they are not available in SPSS. They are only available in R. So the best recommendation that I can give, just imagine that you're cutting this tree at some point, and if you cut it here at 5, at the distance of 5, you'll get 2 clusters, negative affect, positive affect. But if you cut it a little bit to the left, for example, at 4, you'll get 3 clusters, just negative emotions, negative social emotions, and positive emotions. And if you move still a little to the left, you will get like 1, 2, 3, 4 subgroups for negative emotions. And essentially, this is also what you will get if in factor analysis you start requesting more and more factors. You will see the same nuances. But in factor analysis, the model will be very unstable. And you will spend a lot of time comparing all those factor models and thinking, oh, what's different? What's this additional dimension about? And here in cluster analysis, you see it all straight away. And if you have a very large number of items, factor analysis may actually screw up. It might not be able to identify good dimensions. But cluster analysis, it's much more stable, and even in small samples you can use it to find out groups of items that have similar homogeneous content. So what I often do is, if I have a very large number of items and I have a sample that is not so large, so exploratory factor analysis will not give me good results, I start by doing cluster analysis to pick items that I want then to include into my model. So an item like jittery, maybe I would not include. Yeah, and of course you can do the same thing with individuals. Just in SPSS, instead of variables, you say cases. And if you are classifying individuals in statistics, you need to say cluster membership and which solutions do you want to save. Usually it makes sense to start with 2 clusters and end with as many as you want. But obviously you want to have at least maybe 20-30 people in each cluster to be able to compare it meaningfully to other clusters. Here you tell SPSS which solutions you want to save, and after running this cluster analysis, in the end your dataset will be completed by a few more variables that will be called words method, and for each person these variables will reflect the number of clusters into which this person was classified. And then you can use ANOVA to see if those clusters are different, how much variance they capture of the source variables, and you can look at eta squared to quantify it, and how much variance they explain in some other criterion variables. And this way you can establish some kind of external validity. And this is a nice approach. Essentially, it's a person-oriented approach, and it definitely makes sense when you have a very large number of scales, and the relationships between those scales are also kind of complicated. Of course, if you just have 2 variables like anxiety and depression, you don't really need a very complex clustering procedure. But if you have 10 different scales, like the MMPI, for example, it blows our mind when we try to interpret it, and then classifying people into typical profiles might be a very good idea. So to sum it up, cluster analysis is a very simple approach. Unfortunately, it's not so flexible. Every individual can only belong to one cluster. Newer statistical tools, some kind of fuzzy clustering or latent profile analysis, they allow you for every person to quantify the probability with which this person belongs to each cluster. And they are much more flexible. They allow you to adjust variances, correlations within these clusters, whether these parameters will be different or the same for all clusters, and so on. So with modern methods like latent profile, latent class analysis, you can adjust your model much more flexibly. And they are also more robust against all kinds of rubbish. And they are also more efficient in larger data sets. But unfortunately, they are also more complicated, and they are not available in SPSS. And even in R, there are very limited packages so far to do this kind of analysis. It's mainly M+ and dedicated packages like Latent Gold that can do this kind of analysis. So obviously, if you don't have access to any package like this, you can use good old cluster analysis using words method. And for your own master's dissertation, this probably should be quite fine. And even for a publication in a journal that is not a very top journal, this might also work out.